Okay, so let's do a quick review of our topic, compound light microscope. We will do a recall of the basic parts, focusing only on the lenses, and then we'll move on to getting the total magnification and the field of view. Okay, so here's an unlabeled picture of a compound light microscope. Over here is the eyepiece. The eyepiece typically has a magnification power of 10x. 10x means the object is made bigger 10 times. On this part here is the revolving nose piece that holds the three objective lenses. Number 3, it's not so clear because I don't see the color, but over here could be the scanning objective lens with the power of 4x. Number 4 is the low power objective with 10x, and high power objective with 40x. On the lower part of the microscope are the two knobs. The big one is called the coarse knob or coarse adjustment knob, and the smaller one is called the fine adjustment knob. When you're viewing the specimen on the slide, you always begin with either the scanning or the low power. So because you're setting up the slide here, you never start off with the high power. Always begin with the low power or the scanning, and the knob that you're going to use for those, either of those two, will be a coarse knob. Once the object is clearly showing through the eyepiece, you can now switch to high power and just use the fine knob. So let's recall. Eyepiece is 10x. The eyepiece has a lens itself that will make the object bigger 10 times. The revolving nose piece holds the three objective lenses which are color coded. The red one is the scanning with the 4x, yellow one at the back with 10x right there, and the high power 40x, blue. Let's talk about field of view. When you're looking through the microscope, you will see a circle on your view, and that circle is what you call the field of view. So you can get the length or the diameter of your field of view. So remember that it's going to be the point cutting the circle halfway, right there, cutting the circle halfway. So what is a field of view? It's the area of the slide you view through the microscope. And remember this, when you increase the magnification, so for example, you switch from 4 to 10 or from 10 to 100, your field of view decreases. So what does it mean? It means that as you zoom in, you see less of the specimen. So look at the E here. The E here, you see more of it compared to this. Why? Because over here is the zoom version of this E. This is 40x and this one is 100x. Here's another picture, a diagram showing you onion cell and the field of view, which is somewhere here. So it cuts the circle across, okay? And it's represented by those highlighted cells. So along the field of view, it can fit two onion cells. How do we get the field of view of a specimen? How do we get the micron value of a specimen? We can get it by figuring out how much is the field of view and looking at how many cells can fit through that field of view. And there is one conversion that you must memorize, and that is for every 1 millimeter, 1 mm is equal to 1,000 micron. Micron has a symbol of like a UM. Okay, so again, for every 1 millimeter is equal to 1,000 UM. In this example here, it's telling you that this field of view from this point to this point is equal to 1 millimeter. Therefore, from this point to this point is equal to 1,000 micron. And when the slide was placed, there were two cells that were able to fit along the field of view. So that means, what is half of 1 mm? Half of 1 mm is 0.5. And if there are two cells here, that means for this one cell is equal to 0.5 mm. And in microns, it's going to be 500 microns, okay? Let's have another example here. Let's talk about the three pictures representing, well, the cells viewed under the high power, low power, and scanning. So let's start off with the labeled items here. So the eyepiece. Eyepiece would have the 10x magnification and the objective lenses. We're going to focus on this part here. So the scanning will have a 4 times bigger. How do we get the total magnification? We compute it by multiplying the eyepiece with the objective lens. So 10x times 4x, the total magnification power for scanning is 40x. If the field of view in this example is from this point to this point is 4.5 millimeters, the question now is how much will that be in micron? Remember, for every 1 millimeter is equal to 1,000 micron. So what do we just simply have to do? For every 1 mm, 1 is to 1,000. So 4.5 is equal to 4,500 microns. Okay, next item, number of cells. How many cells do we see here? 1, 2, 3, 4. Okay, so along this line, it can fit like 4 cells. So if on the field of view here, it's equal to 4,500 microns, and there are 4 cells that can fit along the field of view. How do we get the size of the cell? We simply divide. So you're going to have 4,500 micron divided by 4 will be equal to, the answer will be, okay, 4,500. I'm doing a little math here using my calculator. Divided by 4, we are going to get 1,125 micron. So which means one cell has the size of 1,125 microns. How did we get that? Again, field of view is 4.5 mm. For every 1 mm is 1,000 micron. So the number of micron for that field of view is 4,500 or 4,500 microns. If there are 4 cells that can fit along the field of view, 4,500 microns divided by 4, you are getting 1,125 micron per cell. Okay, let's look at this example here. So the diameter of the field of view is 400 microns. 450 microns, I'm so sorry. Number of cells across the field of view is 2.1/3. So over here, 2, 1, 2, and 1/3. So the length of one cell, how are you going to do that? You are going to divide 450 micron divided by 2.3 is equal to 195.65 micron. In short, one cell, the length of one cell will be equal to 195.65 rounded off to 196 micron. If there are 6 cells along the field of view, the length here, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, there are 6 of them. And from this point to this point is also 450 microns. 450 divided by 6 is going to be 75 micron. So an onion cell will have 196 micron in length and 75 micron in width. Okay, let's look at another example here. Here's the field of view, and according to the measurement, it is equal to 2 millimeters. Okay, and if each rectangle here represents a cell, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 cells across the field of view. So what's the length of one cell? If the field of view is 2 mm, right there, divided by 8 cells is equal to 0.25 mm. And Again, let's do the conversion. For every 1 mm is equal to 1000 micron. Therefore, for 0.25 millimeter, you are going to have 250 micron. Okay. Oh, this will wrap up our video on micron, basic parts of the microscope, basic lenses, and also total magnification.